Doing every challenge question, part 37. This is Corpio 1, chapter 5, which is the nicest. The volumes of revolution chapter, which is nice. I just get to do some calculus. I'm going to rotate this around the x-axis, so I'm going to do the pi of the integral of y squared dx. Now, this is nice because y squared, this modulus, I don't know whether it's plus or minus, but when I square it, that doesn't matter. So y squared is literally just this thing squared. So that's great. I can just ignore the modulus entirely, basically. Of course, I can expand this out, which gets me this eventually. If I do that properly, I couldn't be bothered. And then I can obviously integrate, nice and easy. At this point, what on earth is this number here? Oh, it's 14 over 4, which is 7 over 2. Yeah, nice. Anyway, then I just put the numbers in. I think I just did it in a calculator. I did, apparently. I could be bothered to do that properly. And you just end up with this. Nice and easy. First question done. Not sure why it was a challenge. Next question is a bit more interesting. We're going to rotate around the y-axis this time, which means our limits are going to be on the y-axis. So we're going to integrate this line here. If I rotate that line around the y-axis, it'll be pi integral between 0 and 8 of x squared dy. So, okay, I need x squared, so let's rearrange this to make this. I'll square that eventually for x. And then what I'm going to do is I'm going to take away this empty area here, or empty volume, I should say. If that's rotated around the y-axis, that's the integral between 1 and 8 of x squared. So I need to rearrange this for x squared as well. That's slightly more complicated as to how you would do that. I chose to cube root, which got me this. 64 cube root is, of course, 4. And then I can just call that y to the minus a third. And then if I square everything, I end up with 16 y to the minus 2/3. And if I square this, I end up with this here. And I think if I just do this minus that, I should be good to go. So yeah, let's do that. I chose to take out the 64 here. 8 squared is 64, just take it out. And then I squared 40 minus 3y to make this. And then I took the 16 out as well, and now I can just do some very simple integrating. I can input some numbers in a calculator because I can't be bothered to do this properly, and you end up with a nice number of 56 pi if you just keep going with that. Good. Next one then is, again, rotation around the y-axis. I think I can completely ignore this line. What I intend to do here is rotate this line from 0 to 4, pi integral of between 0 and 4 of x squared around this way. And then I'll take away the integral between 3 and 4 of this one going around. And I think that will end up with the whole area. So okay, rearrange this for x, you get this. I'm going to have to square that, of course. Rearrange this for x. I squared it there, I guess. Rearrange this for x is actually nice and easy, just minus a third and then times by 9. That gives you x squared immediately. So, of course, I'm going to integrate this one between 0 and 4, and then take away this one between 3 and 4. And that'll be my plan. And if I just do that, I'm just going to do some very simple integrating. And I'm going to put the numbers in, and I'm going to get an answer, which is going to be correct. And that's all I need to do there. Next one is a little proof. Basically, every teacher should do this in class time, like for sure. It's just a thing that everyone should do. This blue area is clearly got radius y, so it's just pi times y squared. But y, you can see by Pythagoras, is r squared minus x squared square rooted. So y squared is r squared minus x squared. I'm not sure why they really asked you to do that, because I'm not really going to use it. All I'm going to do is say that the equation of this circle here is x squared plus y squared equals r squared. I'm just going to consider the top half of it. If I consider the top half and integrate around the y-axis, I think I'm going to integrate, yeah, I am. Integrate around the y-axis between 0 and r of x squared, therefore. If I do that and then just times the answer by 2, I'll get the entire sphere. So I think the volume is just 2 lots of pi integral between 0 and r of x squared, which means I'm rotating around this way. X squared is, of course, just this. I can just integrate that, and then I can put the r's in. This makes r cubed, this makes a third r cubed, put in 0, you get nothing, so that makes 2/3 r cubed, times it by 2 pi, and you end up with 4/3 pi r cubed, which is indeed the volume of a sphere. Good, I think that's the whole question done.